Hi guys, I'm Edward. I'll be presenting the solution to the Washington Gold TST number 9, another problem written by Daniel Huang. So the problem says that you have these 12 integers, positive integers, a1 to a12, and you're given this strange identity for all n between 4 and 12. So when you do this kind of problem, it's probably best to just start out by writing out like the thing for small values of n. So for example, when n is 4, you get 4 times this sum, a1 squared plus a2 squared plus a3 squared plus a4 squared. And you see that this is equal to a1 plus a2 plus a3 plus a4 squared. Okay, so now we have this. We might recognize this from several sources. There should not be a squared here. You might recognize this from several places, notably Cauchy-Schwarz, or just AMQM. Either one works, and this tells you that 4 times a1 squared plus a2 squared plus a3 squared plus a4 squared should be larger than or equal to a1 plus a2 plus a3 plus a4. So this is kind of interesting because we have this equality case of an inequality, and if you're familiar with the equality case of AMQM, this actually tells you that a1 is equal to a2 is equal to a3 is equal to a4. Okay, so this is actually pretty helpful. So now what we're going to do is we're going to look at our identity again. So we're going to look at 4 times a1 squared plus a2 squared, etc., all the way to an minus 1 squared, and this is equal to a1 plus a2 plus all the way to an minus 1 squared. Right? And actually what we can do is we can just subtract this. So in particular, we find that we have this as well, because like obviously. And then when we subtract these two equations, we will actually get 4an squared on this side, and we're going to get an squared plus 2an times a1 plus all the way through an minus 1 here. Okay, so now I can move this over, and we easily see that an is equal to 2/3 of the sum of a1 through an minus 1. So now we're pretty happy because we kind of have a general idea of what we're going to do now. All we need to do is just calculate a closed form for an. And basically, we can do this by induction. So an is equal to 2/3 of an minus 1 plus 2/3 of an minus 2 through an minus 1, which you probably recognize as an minus 1, right? So as a result, you're just kind of done because this tells you an is 5/3 an minus 1. As a result, a12 should just be equal to 5/3 times a11 equals to 5/3 squared times a10, etc. And what this does is it tells you that a12 is actually 5/3 to the 7 times a5, which means that it's 5 to the 7 over 3 to the 7 times 8 times a1. Because like a1 was 8/5, a5 was 8/5, a1. Okay, so now we have this. So you know that a12 has to be an integer, so therefore it must be at least 5 to the 7 times 8. And to make sure that this is correct, if we set a1 to be 3 to the 7, then we indeed get a12 as 5 to the 7 times 8, and everything in between is also integer, so we're done. And the answer is 5 to the 7 times 8.